Hello class, welcome to this review for the midterm. So I went ahead and changed up some of the numbers in the problems. So this is completely different, same problems but different numbers. So let's get started with simplifying radicals for complex numbers. So we have square root of negative 64 and square root of negative 48. So how do we do that? So let's look at first one. Well, first off, we know that we can't do the square root of negative 64 because in the real numbers, because you can't do negative 8 times negative 8 because that'll give you positive 64. So there's no way that you can use a real number for this. So this is going to be imaginary. But we do know that 8 times 8 is 64. So basically, break this up into square root of 64 and square root of negative 1. And square root of negative 1 is equal to I. That's what we call I. So square root of 64 is 8, and so it becomes 8I. So you can go straight from this to the answer by saying, okay, well, square root of 64 is 8, and then since it's negative, it's imaginary. So similarly, we're going to be doing the same kind of thing for the second one. Well, we know this is negative, so I know it's whatever square root of 48 is times I, right? Since it's negative inside. But then, we run into the problem, well, this is not a perfect square. So since it's not a perfect square, you're going to break it down as much as you can. So 48 breaks into, let's see, 2 times 24. Circle your primes. You can't do that anymore, so that stops. 2 and 12. Oops, I don't want to circle that because I can keep going with 12. 2 and 6. 2 and 3. And that's it. We can't go any further for factoring. So now you're going to box your pairs. So I see a pair of 2's here. I see another pair of 2's here. So this means that the boxed part goes out, the rest goes in. So this boxed part goes out as a 2. This goes out as a 2. And then you got to times those two 2's together, right? So you got to times them. And so you get 4. Okay, so far we have a 4 on the outside of the radical. And then of course we have the I, kind of hanging out there. And so the rest, which is the 3 here, goes in. All right, so you can write this like this, or you can write it as 4I square root of 3. It doesn't really matter too much, as long as you have the I on the outside somewhere, okay? All right, so that's how we take care of those two problems. So let's go back to the third, multiplying complex numbers. So you got to know how to multiply basically numbers that have imaginary components to them. So let's start with that then. All right, so for number 3, we have 1 minus 2I, 3 plus 5I. So in order to do this, you have to do a FOIL. So we're going to be multiplying 1 times 3 together, which is 3. Next, we're going to be multiplying 1 times 5I, which is positive 5I. Next, you're going to be multiplying negative 2I times 3, which is negative 6I. And finally, you're going to be multiplying negative 2I times 5I, which is negative 10I squared. Now keep in mind that I squared is equal to negative 1. And so we're going to have to plug this in for I squared here. And keeping in mind also that we'll combine our like terms. Okay, so we can combine these two. We have 3 plus, and 5 minus 6 is negative 1, right? So really this is negative 1I. I'm not going to write the invisible 1 there though. Minus 10. Now replace this I squared with negative 1. So now we have here 3 minus I. Negative 10 times negative 1 is positive 10. Combine your like terms now. 3 plus 10 is 13. So we have 13 minus I. Make sure that when you write this answer, you write it in the form a plus bi, because that's the standard form for complex numbers. So standard form. Okay, so that is our final answer for number 3. So moving on to number 4. All right, so what is the end behavior of the graph of y equals 3 minus, let me zoom in on that, 3 minus 3x to the fourth plus x squared minus 2x. So we're focusing just on the end behavior. So let's write out the function. So if you want to do end behavior, well, you gotta look at the four cases, right? So we have the cases for end behavior. Okay, so the first case is, and we'll just say this is the first case, is when you have an even degree and a positive leading coefficient. Second case is when you have an even degree and a negative leading coefficient. Then you have your third case, which is odd degree, positive leading coefficient, and then lastly, odd degree and negative leading coefficient. So if you have an even degree, that means that your highest power is like 2 or 4. That's your highest power, right? So if it's even is always going to behave like a parabola, like a quadratic function. Remember that a parabola looks like this, right? The U shape. So it has that shape. So if it's even, it's going to resemble this if it's positive. If it's even negative, it's going to resemble, you know, the upside down parabola, right? So downturned. So that means that if it's going, if it does a U shape, that means the end behavior is going to be up and up. Okay, so I'm not going to ask you to do the infinity notation here. I'm just going to ask you to describe the end behavior. So that means on the left side is up, on the right side is up. Okay, so just describe it on the test. And, I remember last time I asked you to do infinity, but I won't ask you for this midterm. All right, so now for the even degree, negative, since it's a downturn parabola, both arrows are going down, so it's going to be down, down. Okay, so now for the odd degree, when I think of odd degree, I think of like, you know, I think of a line, right? X. So if I had y equals x, right? X to the first power, 1 is odd. So x to the first power, you know, that would be an odd degree. And that's a line, right? If you graph that, that's a line that goes up like this. Which means that this arrow is going down, this arrow is going up. So when it's positive leading coefficient, the end behavior is down and then up. Now, if we had something like y equals negative x, well, that's a negative leading coefficient, but an odd degree, odd power, which, and remember, negative x just looks like this. It just goes down. So that means that the left side, the arrow is going up, the right side, the arrow is going down. So we have up and then down. Okay, so that's a way that you can tell the end behavior for odd and even degrees. So how does this relate to our problem? Well, you're going to identify the degree of number 4. So what's the degree? Degree is the highest power, the highest power for a variable or combination of so. So we have, it's 4. The leading coefficient here is the number multiplying the highest power of x or whatever variable, which is in this case negative 3. So we have leading coefficient is negative 3. So that means we have even degree and negative leading coefficient, which means that the end behavior, if it's even and negative, it's down and down. And that's all I was looking for number 4. All right, let's do number 5. That's another end behavior problem. So negative x minus 1/2 x cubed plus x squared. So again, the highest power is 3. So this is odd, so odd degree. The leading coefficient is negative 1/2, so that's odd degree, negative leading coefficient, which means that we're looking at one of those 4 cases, which is odd and negative, so it goes up and then down. So that is end behavior. All right, so now let's look at number 6. We have use the remainder theorem to find the remainder from the polynomial long division. All right, so we just have to find the remainder using the remainder theorem. Okay, so let's write out the problem for number 6. So we have 2x cubed plus x squared minus 10x plus 3, and we're simply dividing this by x plus 3. But we're only interested in the remainder. Okay, so this means we're going to be using the remainder theorem. So the remainder theorem, you have to basically figure out what makes the divisor equal to 0. Okay, so the divisor here, set the divisor equal to 0. The divisor here is x plus 3. And then solve that. So basically you have subtract 3, so we have negative 3. Okay, so set that divisor equal to 0, basically, and then get what that number, the x equals negative 3. All right, so that's how I like to think of it. Set it to 0, solve it, you get your number, and then you can take that number and you plug it into the dividend. All right, so plug into your dividend. Here we'll call this dividend f of x. So really you're doing f of negative 3, okay? And that will give you a remainder. So we're plugging in negative 3 into that dividend. So we have here 2 times x cubed, but x is negative 3, plus x squared minus 10 times x plus 3. And then we simply do the math here. So we have 2, remember to follow PEMDAS. So exponent goes first here before you multiply. So don't do negative 6 and then to the third. You have to do negative 3 to the third. So negative 3 to the third is negative 27. Negative 3 squared is 9. And then you can multiply these. Negative 10 times negative 3 is positive 30. And then plus 3. And then we'll multiply these now. Negative 54 plus 9 plus 30 plus 3. All right. So 39, 42. So this would be negative 12. F of negative 3 is negative 12, which is our remainder. All right. Let's go ahead and look at the next one. The next one is another remainder theorem problem. So 7, we have x squared minus 6x plus, 6x cubed plus 1 divided by x minus 1. Again, using the remainder theorem, which means we have to set our divisor equal to 0, solve that, and then we plug that into our dividend. So we're going to call our dividend f of x. So really we're doing f of 1. So we have 1 squared minus 6 times 1 cubed plus 1. All right, so now we got to do 1. 1 squared is 1. 1 cubed is 1. 6 times 1 is 6. And so here you have negative 4 for your remainder. All right, that's all there is to it. All right, let's look at the next one. So number 8 is asking us to do perform polynomial long division. All right, so just long division, not synthetic or anything, any other technique. Just what we've been doing in class. All right, so let's do that one. So we have here 3x cubed minus 4x to the 4th plus x minus 3 divided by x minus 2. Which sometimes you can see this written as this, as a fraction. So if you see it written as a fraction, that means the same thing, okay? So make sure that this right here is in standard form first, okay? So let's convert it over to standard form before we even do anything. So Remember, standard form is highest power to lowest power. So this right here is the highest power. So we're going to do this one first because that's the highest. All right. So negative 4x to the fourth plus 3x cubed. Now the next one is plus x and then minus 3. So plus x minus 3. And then if there are any gaps in the powers, go ahead and fill those in now. So we had plus x minus 3. So this is a 4 power, 3. We're missing a squared. So let's go ahead and fill that in with a 0x squared. Make sure you fill in any gaps in the powers. All right. So now we can go ahead and proceed with the long division. So the top is the dividend, and it goes inside. The bottom goes on the outside. All right, so we'll proceed with the long division here. So remember, the idea is that you want to get negative 4x to the fourth. Okay, so you're going to put that down. But how do we get that from x? So what times x is negative 4x to the fourth? Well, I know that if I do negative 4x cubed and I times it by x, I get negative 4x to the fourth. And then if I do this times negative 2, I'll get positive 8x to the third. And then I will subtract. So this is going to cancel. You got 3 minus 8 is negative 5x cubed. Make sure you bring down the next number, 0x squared, and then proceed. We want to get negative 5x cubed. So how do we get that from x? Well, I know that if I times x by negative 5x squared, if I multiply by that, I get negative 5x cubed. And then negative 5x squared times negative 2 is positive 10x squared. Then I subtract. Double negative here is a positive, so basically these cancel. Now you have 0 minus 10, so you can convert this to a negative if you like. 0 minus 10 is negative 10x squared. Bring down the x. So now I know I want a negative 10x squared. How do I get that from x? Well, I know if I multiply x by negative 10, I will get negative 10x squared. Negative 10x times negative 2 is positive 20. All right, so now I know that I need to subtract. This double negative turns into a positive. That cancels. This is a 20x. And then I got 1 minus 20 is negative 19x. Bring down the minus 3. So I want to get a minus 19 here. How do I get that from x? Well, if I multiply x by negative 19, I get negative 19x. Negative 19 times negative 2 is negative 38, and then I can subtract. Double negative is a positive, so this cancels. Oh, wait, negative 19 times negative 2 is positive 38. I apologize for that. Negative 19 times negative 2 is positive 38. And now we have negative 3 take away 38 is negative 41. So that's our remainder. We can't do anything else from that. Okay, so this is our remainder. So then our final answer, right? We're going to put our final answer in quotient form. That's usually what they prefer it as. Okay, so we're going to take our quotient here and we're going to add our remainder to it. So plus remainder over divisor. And then that will be your final answer. So I'll go ahead and rewrite that answer off to the side. So our final solution in quotient form, negative 4x to the third minus 5x squared minus 10x minus 19. You can write this as plus negative 41, or you can simply write it as minus 41 over x minus 2. It doesn't matter. They both mean the same thing. All right, so that was long division. Let's move on to the next type of problem. So we have here number 9. This is going to be a long one, so buckle up. This in general, this review. So number 9, negative. So we want to graph and identify the transformations of the quadratic functions. So just transformations and a basic graph. So we have y equals negative 2 x minus 3 squared plus 5. So remember that this resembles the vertex form of a parabola, which if you recall is a times x minus h squared plus k. Remember that if h is positive, this indicates that it's a shift to the right. If k is positive, this indicates that it's a shift up, okay? If h is negative, it's going to be a shift left. If k is negative, it's going to be a shift down, all right? So it's going to be the opposite. Remember that if a is negative, this means that the graph goes down instead of up, okay? So it reflects or flips down, okay? So it reflects. All right, and also if a is greater than 1, it's a vertical stretch. If a is between 0 and 1, well, it's a vertical compression. Okay, so just a quick few little things, but all that we're concerned with for doing the graph is basically these three things, okay? Now, if a is positive, right? If a is positive, then obviously it's going to just be the parabola shape, right? Like this, if a is positive. So that means that we're able to graph it if we identify at least these three things. All right, so I just want to sketch because you want to be able to match it to the graph on the test. All right, so we know that a here is -2. Just comparing those two things, a has to be -2. So a is negative, so that means the graph is going to look like this. It's going to flip, right? Now, if you compare these two directly, h is actually +3. So the guideline is if the signs match, if these two signs match, then the answer is going to be, positive for, for h or k. So in this case, it's +3. Now, if you look at your, let me just kind of circle these guidelines separated from my solution here. All right, so now k, if you notice this, k, the signs match, so that means it's going to be positive, and k is clearly 5. All right, so now we identified a, h, and k, so this means it's shifting right 3 units. This is shifting up 5 units. And since it's negative, it's a reflection. This is a reflection about the x-axis. All right. So that means that we're ready to graph it. So that means we're going to go right 3, up 5. So remember that the vertex usually starts in the middle, right? But that's going to be shifted. So if it starts in the middle, then it's going to be 1, 2, 3. It's going to be up here, and then up 5. 1, 2, 3, 4, 5. So now this is your vertex now. And you're just going to have, and we know it's downturned, right? So we're going to graph it so it's downturned. Like I said, I am not interested in the specifics of the graph. As far as, where it crosses the x-axis at this point, the question is just going to ask you for a basic sketch. You just got to match it to that sketch. And in order to match it, you need to be able to identify the vertex. That is the most important feature right now that I am focusing on, as well as whether it's reflected or not, okay? So just for this question, that serves its purpose right there. All right, so let's look at the next one. So number 10. So number 10 is another, so again, same deal. This is in vertex form. Remember, vertex form is a x minus h squared plus k. So let's identify our h. So let's do a. A is clearly going to be 4 if you see them. H, the signs do not match. This is negative and that's positive, so it's going to be -1. K, the signs do not match. Positive, negative, so it's going to be -6. All right, so if it's negative, h is negative, it's left 1 unit in this case. Since k is negative, so it's down instead of up. So down 6 units. And since a is 4, a is positive, this means that the graph's going to be the U shape. So we have left 1 unit, and then down 6 units. 1, 2, 3, 4, 5, 6. All right, and then it's going to be the traditional, U shape. Okay. So if you know that information, you should be able to match it because it's going to be a match kind of thing, with a multiple choice for that. You can choose the graph just based off of that. Okay. All right. So number 11. All right, number 11 wants you to graph, again, another parabola, another quadratic function, but it's in standard form. So we'll need to practice doing that. All right, so let's write our parabola, our quadratic function. So the graph of this, we know it's going to be a parabola. Is it going to be up or down? Well, it depends on this here. This is negative, right? This is A. So A is negative, which means that this is going to be reflected like that, okay? Kind of like it was before. So in order to do this, we're going to need to find the vertex. So let's find the vertex. So the formula to find the x-coordinate of the vertex. So to find the x-coordinate of the vertex, we use negative b over 2a. Okay, so we use that formula to find the x-coordinate of the vertex. Well, we said that this is A, this is B, and this is C. So B is negative, it's 2, so we have negative, and then plug in the 2 for B, over 2 times A. A is negative 4. Here we don't really need C, but it's good to know what it is nevertheless. Okay, so we have that, so we have negative 2 over 2 times negative 4 is negative 8. So we have here, this reduces to 1/4. All right, so we have our x-coordinate of our vertex. So far, our x-coordinate for our vertex is 1/4. If you want, you can write that as a decimal, whatever. I'm just going to leave it as a fraction, okay? All right, so now what we do is take that 1/4 and we plug it into the original function for x. So you plug in. So if we do that, we get y equals negative 4 times x squared, which is now going to be 1/4 squared. Plus 2 times x, which is now going to be 1/4 minus 1. So we have 1/4 squared. How do we square a fraction? Well, you simply square the numerator and denominator. So 1 squared is 1, 4 squared is 16. So we have negative 4 times 1 over 16. And then 2 times 1/4, you just multiply the numerators, the 2 times 1, and then the invisible denominator 1 times 4. So 2 times 1 is 2, 4 times 1 is 4. All right, same deal here. So we have here negative 4 times 1 is negative 4, and then invisible 1 on the bottom times 16 is 16. And this reduces to 1/4, negative 1/4. So let's reduce this. Let's divide this by 4, top and bottom. Let's bring everything else down. So let's be negative 1/4 plus 2/4 minus 1. So this will be 1/4 minus 1. And 1 is the same thing as 1 over 1. We need a common denominator of 4, so I'm going to times it by 4. And if you subtract those, you get negative 3/4. All right, so that is our y-coordinate, and that belongs here. So now we know our vertex, so we know our h, we know our k. So we can proceed to graph. Okay, so that means that when we graph our vertex, we have 1 here, 1, 1, negative 1, negative 1. So our vertex is 1/4 and negative 3/4. So it's around here. And we know it's downturned. So we know it's going to be downturned. So flipped down. All right, and that's our sketch of our graph. Okay, so I'm just interested in this sketch. All right, if you're more comfortable with the decimal, then at this point, you would plug the decimal into the calculator instead of the fraction. All right, so let's go to number 12. Write the equation of the parabola in vertex form, given the vertex and a point that it passes. So here we have our vertex is, remember that this is given by hk. So we were given h and k. All right, so here, let's look at 12. We have y equals negative 4x squared. Or I'm sorry, I'm looking at the other problem. The vertex is given by negative 2, negative 3. Our point is given by 1, 5. Okay, so remember that the vertex form is given by y equals ax minus h squared plus k. So remember that the vertex that they give you is h and that is k. So they already give you the h, they already give you the k. So we know here that h is negative 2 and k is negative 3. So we can take that and plug it in. So we have y equals ax minus, there's a minus from the formula, but h is also negative, isn't it? So we're going to plug in another negative. Squared plus, and then k is negative, so my plus negative 3. Now plus negative 3 is the same thing as minus, so it's going to be minus 3. 2 negatives is the same thing as a plus, so we're going to write that as plus 2 squared. Alright, how do we find a then? Well, to find a, we use these coordinates. So this is x, this is y. So we know here x is 1 when y is 5. So we're going to plug that in. So y is 5, a, x is 1 plus 2 squared minus 3. So 5 equals a, 1 plus 2 is 3, so we have 3 squared minus 3. So 5 equals a, well, 3 squared is 9, so let's write this as 9a minus 3. Solve this equation for a, so we got to add 3 to both sides. Divide by 9 on both sides. And so that means that a is 8 over 9. You take that 8 over 9, you plug it into here, and you get your final solution. Okay, so our solution is y equals 8 over 9, parentheses, x plus 2 squared minus 3. And that's how you find the vertex form. So plug in your hk, then plug in xy only to find a. And then once you find a using xy, then just replace xy with, leave xy as xy, and then plug in a. And you have a, h, and k. All right, so let's move on to 13. So 13 is asking for you to multiply two polynomials. So you're multiplying those polynomials together. So it's just foiling with those guys. All right, so we have here 2x to the third plus 3x minus 1 times 4x to the third minus 5x plus 3. All right, so we're just timesing them together. So you're going to do this first, this times this. So that's going to be 8x to the 6th power because you have a total of 6 x's there, 3 and 3. Now you're going to do this times negative 5x. So 2 times negative 5 is negative 10. X to the, you have a total of 4 x's there, 3 there and 1 there. Then you do this times the 3. So it'll be plus 6x to the third. All right, now you go 3x times 4x cubed. So it's positive 12x to the 4th. You have a total of 4 x's there. Positive 3x times negative 5x is negative 15x, total of 2 x's, so squared. 3x to the first power times positive 3 is positive 9x. All right, we're going to continue. Negative 1 times 4x cubed is negative 4x cubed. Negative 1 times negative 5x is positive 5x. And then negative 1 times positive 3 is negative 3. So a lot of terms there. So now we combine our like terms. So we have no like terms for 8x to the 6th, so we're going to bring this down. All right, so that's done. We have negative 10x to the 4th and positive 12x to the 4th. So let's combine those two together. That'll give you positive 2x to the 4th. So that's done. We have 6x cubed and negative 4x cubed. That's going to be a positive 2x cubed. So those are done. We don't have any negative 15x squared, so bring that down. That's done. We have a 9x and a 5x, which is 14x. So that's done. And then we have a negative 3. Bring that down. And that's your polynomial. All right. Let's move on to number 14, which is solving the system algebraically. So we want to solve this using either elimination or substitution. All right, so 14, let's write out the system. Okay, so solving this system, we have, so this is an elimination type of problem. Okay, so we need to use elimination. How do we know that we use elimination? Well, elimination is when you have both variables on one side. It makes it easier to use it when both variables are on one side, so that way you can eliminate one of the variables. Okay. So our goal is to eliminate a variable. So we're gonna eliminate x. You get to choose the variable, but it's easier to eliminate x. In order to eliminate x here, well, you have to multiply both sides by. You have to multiply this by 2. Because we need the 16s to match. Okay, so we're gonna times this by 2, and if we times this by 2, we gotta multiply everything by 2. So our goal here is to make the coefficients match. Okay, so we need this to be a 16. All right, so if we do that, let me make this a little bit. Okay. So if we do that, we got 2 times 8 is 16, so we have 16x minus 2 times 6 is 12, so 12y. 2 times negative 20 is negative 40. So we multiply everything on the top by 2, and now you can see that if I rewrite the bottom below it, then now these coefficients match, 16, right? So now we can either add or subtract to eliminate them. Now, I have to add here because if I subtract, I'm going to get positive 32 because 16 take away negative 16 is going to be 32. The goal here is to make it 0. So therefore, I am going to add the two things. 16 plus negative 16, that's 0. So this goes away. All right, so negative 12 plus 7 is negative 5y. Negative 40 plus 30 is negative 10. So now we have here a very basic equation. We can solve this by dividing by negative 5 to get our y. So y equals 2. Once you get one of the variables, remember to plug back in. So we're going to plug this variable back into one of the equations. Let's plug it into the first one. So we have 8x minus 6 times 2. Now we're plugging in 2 for y equals negative 20. Solve this. 8x minus 12 equals negative 20. Add 12 on both sides. 8x equals negative 8. Divide by 8 on both sides. And we have x is negative 1. So put your two solutions together. We have negative 1 comma 2. And that's our final solution. All right, let's look at the next system. So we have number 15 is, so we have a system with y equals 4x minus 9. Next one is 2x plus 3y equals 1. So this is a substitution type of problem. So you want to use substitution here. How do I know to use substitution? Well, if you look at the problem, you see that y is by itself. So I can plug in for y or substitute this into y in the other equation because 4x minus 9 is equal to y on top. So it should be also equal to the same thing on the bottom. So I can plug in for y onto the bottom. This is called substitution. So now if we substitute y, then this equation on the bottom now becomes 2x plus 3. Now y gets replaced with 4x minus 9 equals 1. All right, so now it's been substituted. Now we can solve it. So let's make sure to distribute. So we have 2x plus 3 times 4 is 12, 12x. 3 times negative 9 is negative 27. Combine your like terms. So 12x and 2x is 14x minus 27 equals 1. Now we'll solve this by adding 27 on both sides and then dividing by 14. And so x is equal to 2. All right, so then once you get that, you plug it into any one of the equations. Well, we're going to plug it into this one because it's easy to plug into that one. And we do that, we get y equals 4 times x is now 2 minus 9. 8 minus 9 is negative 1. Put your two answers together to get your final solution. And that's how you solve it. Solve linear systems algebraically in both methods. Right, we're going to look at number 16 now. 16 is, let's look back at the original document. Right, so what is the maximum or the minimum value? What is the range for the following function? All right, so let's look at it. So we have y equals negative 12, or negative 2, I mean, x squared plus 14x minus 5. All right, so that means that if we want to find the maximum or minimum and then the range, right, then first off, we need to figure out what the vertex is, because this is a parabola, so it has a vertex. We need to find that. So let's find the vertex. Remember, to find it, you use the formula negative b over 2a, just to make it easier. A is negative 2, b is 14, and c is negative 55, but you won't need c here. You'll just need a and b. So we have negative b over 2a. So you have negative 14 over negative 4, which reduces to negative 7 over 2, which as a decimal is negative 3.5. So I'll just do it as a decimal this time. All right, so then we'll plug, so we have vertex is negative 3.5. Let's plug this in to our original so that we can get our y coordinate of our vertex. Negative 2 times negative 3.5 squared plus 14 times negative 3.5 minus 5. So we're going to quickly get this on here. I'm going to zoom in on this real quick. And we'll get this number. Minus 5. All right, so if we do this, we get all right, so we get negative 78.5. All right, so negative 78.5. So that means that we have our HK. So now if we look at A is negative, right? Because it's negative 2. So if it's negative, that means it's flipped down like that. So if we were to graph this, right, would have negative 3.5, and then all the way down is negative 78.5. So all the way around down here. And then it's going to be flipped down. So this means that we have a maximum. So if you look at this graph, we have a maximum that is equal to negative 78.5. That's our top part of our graph, right? So we have maximum, and then our range, if you look at it, the range is the y values. So this the y values go from negative infinity down here all the way to negative 78.5. So that means that our range is y has to be less than negative 78.5 or equal to. All right, so it's below negative 78.5, that's why it's less than. And another way to write this is negative infinity to negative 78.5. And then you can use a bracket for negative 78.5 because you include that number. All right, so let's go to the next problem. So we're looking at here, evaluate the series from 1 to 45 of 2x minus 5. All right, so we're gonna have to review series real quick. We haven't done that in a while. Okay, so we want to do the sum from x is 1 to 45 of 2x minus 5. All right, so in order to do this, we know that this is a series, so we need to use the sum formula, okay? So first off, what is this actually saying? Well, this is saying that you're adding the terms from when you plug in 1 and then all the way to 45. So you'll plug in 1, then 2, then 3, then 4, all the way to 45. So this means if I were to plug in 1 here, right, I would get 2 times 1 minus 5, whatever that is, plus, and then now I'll plug in 2 into it, plus, and then I'll plug in 3 into x instead, and I repeat that all the way to I get to 45. Now, are we going to do all of that, all of those numbers, and calculate them? No. We have a shortcut to do this, right? So before I do that, though, let me calculate the first few terms here. So 2 times 1 is 2. 2 minus 5 is negative 3. 2 times 2 is 4. 4 minus 5 is negative 1. So we have negative 3 plus negative 1 plus 2 times 3 is 6. 6 minus 5 is 1, and so on. Now, can you see a pattern here? Well, the pattern is it's going by plus 2's. So the pattern here is called our common difference. So this right here is our common difference. This is an arithmetic series. So this is what we call an arithmetic series. The formula for the arithmetic series I will give you in a little bit. But the common difference here is d, and it's equal to positive 2. So the pattern is going by 2's. That's your common difference, which we call d. Let's give you the formula for the sum for the series. So to find the series formula, its sum is equal to, we'll call it Sn. Okay, so Sn is equal to A1 times all right, oops, shouldn't be A1, sorry. It's going to be N N over 2 times A1 plus, okay, well, we'll rewrite it this way, sorry. It looks a little weird that way. I don't want to write it like that way. So it's A1 plus AN over 2 times N. I'll write it that way. Okay, so A1 plus AN over 2 times N. So that's our series or sum formula, for arithmetic series only. Okay, so this is for arithmetic series. So in order to do this, well, N is the number of terms that we want, right? Like the sum of the number of terms. So in this case, N is 45, since we want 45 terms. Okay, so we want N is equal to 45. And A1, remember A1 is the first term in our sequence. So our first term is negative 3, so that's A1. Okay, so A1 is negative 3. Now AN, AN is our last term. So in this case, AN is A45, because remember N is 45, right? So we're plugging in 45 into N. So A45 is our final term in this sequence. How do we find that? Well, we just plug in 45 into X here. Okay, so we're going to plug in 45 now. If we do that, well, that's this guy right here, right? 2 times 45 minus 5. So if you do that, you get plus, well, 2 times 45 is 90. 90 minus 5 is 85. And this is our AN, which is the same thing as our A45 in this case. All right, so A45 is now, we know it's 85. So we have everything we need to plug into the sum. So we're looking for sum of the first 45 terms is equal to A1 plus A45 over 2 times 45 terms for n. So this is going to give us 82 over 2 times 45. 82 over 2 is 41. And we got to do 41 times 45. Do that on the calculator real quick. Yeah, 1,845. And that's our sum. That's our final solution. All right, so that's how you deal with series. So again, to deal with series, you're going to use their sum formula, identify A1 by plugging in 1 into the formula that they give you for the sequence. Plug in 1, then plug in the final number that they want, because that's AN. In this case, the final number is given by, the top number here. You plug that in as well to get AN, and then you figure out what the pattern is, which in this case is going by 2's, to get D, right? That's how you get D here. And really, you don't even need D, actually. So you don't even need to do the pattern. You don't have to find D in this example. So you can ignore D if you want. I just wanted to review common difference because we're going to do this later. So you don't even need D. All you need is A1, AN, and then N, and then you're fine. All right, so now let's do speaking of D and using the sequence, this is where we're going to use it. So we want to find the 94th term in the sequence, 5, 9, and 13. Okay, so, all right, let's write out the problem real quick. So we have here number 18. And we want the 94th term. So you see this is separated by commas, so it's just a list of numbers. So this is a sequence, as opposed to the series where we added the terms, right? This one we're not adding, we're just finding the pattern. All right, so here the pattern is going by 4's. And this is your common difference, okay? So your common difference D is positive 4. Tuck that away because we're going to need that. Now to figure out the 94th term, if we're finding the 94th term, this means n is 94. Okay? All right, A1, that's 5. So A1, the first term is 5. So we'll need to figure out a term in the sequence. This is an arithmetic sequence, by the way. An arithmetic sequence is when you have a pattern of numbers in which you have to add the same number to get to the next, or subtract. So here we're adding the same number, 4. So the formula for the arithmetic sequence is AN equals A1 plus D times n minus 1. Okay, so that's our formula. Now you know why we need the D, right? And A1 and n. So now we can find A94. We're finding the 94th term. A1 we said was 5. So the first term was 5. D, the pattern is 4. N is 94, which I'm finding the 94th term. And then all we got to do is just do the math on the calculator. So we have 4 times 93. We got to do 4 times 93, which is going to be 372, if I did that correctly. And then 5 plus 372 is 377. So the 94th term is 377. And that's all you have to do for those types of problems. All right. let's see if we can wrap this up. So we have number 19. We want to factor or use identities to factor. All right, so let's see about factoring this. We want to, we just want to factor, we don't want to solve. Okay. Number 19, we have 5x squared plus 8x minus 4. So if we want to factor this, we're going to have to see if we can set up an x table. But you see that there's a term here, right? You see an a here and a c here. If there's an a that is not invisible, right? So like if a is 2, 3, 4, something that is not 1, then you got to use AC method. All right, so we got to use the AC method here. So we got to do 5 times negative 4. Well, that's negative 20. The middle number goes on the bottom. You need to find two numbers that multiply to negative 20, but add up to 8. So that would be, let's see here, 5 and 4, that gives you 9, right? 2 and 10. But it'd be negative 2 and positive 10. So that multiplies to negative 20, but adds up to positive 8. So now next you want to take those two numbers, negative 2 and positive 10, and split the middle term into those two numbers. So we're going to split it into 10x and negative 2x, which are these two numbers that we used. Okay. It doesn't matter if you did negative 2x first and then positive 10x. It doesn't matter. You just have to split it into both of those. Remember to include the x. All right, now bring down the 5x squared. And this is a positive 10, so I'm going to put plus there. Bring down the negative 4. Now you're going to factor by grouping. So in this case, you're going to you can pull out a 5x from this first group. So I know that 5x times x is 5x squared. I know that 5x times 2 is 10x. So we're back to our original. From the second group, I can pull out a negative 2 in common. Negative 2 times x is negative 2x. Negative 2 times positive 2 is negative 4. So now I can rewrite one of these as my factor. And then these can be written as another factor, 5x minus 2. All right, so we officially factored it. That's it. All right, so let's switch gears to number 20. Number 20 is another factoring problem, and it's 64x squared minus 49. So this is actually a difference of squares. Difference of squares. How do I know that? Well, I know that the square root of 64 is 8, and I know that the square root of 49 is 7. So I know that those are perfect squares. So I know that if I convert this, so this is going to be a squared minus b squared. That's the formula for difference of squares, equals a plus b times a minus b. So if I want to factor this, I just got to rewrite it like this. So in this case, a is going to be 8x. Okay, so a in this case is 8x, because 8 squared is 64. And then b is going to be 7, because 7 squared is 49. So now in this case, I have 8x for a plus 7 for b. 8x for a minus 7 for b. Done. Once I take the square roots, I can plug it into a and b into the formula, and I'm done. All right, so now 21. Let's see what it was asking for. So 21 is find, let's see. So they give you one of the zeros of x cubed plus 5x squared, okay, minus 8x minus 48. They said one of the zeros is x equals 3. Use long division to factor the polynomial. What are the zeros or multiplicities? How does it behave at each zero? Okay, so since they give us one of the zeros, we need to do long division here to find the rest of them. All right, so let's do that real quick. Now we have here x cubed plus 5x squared minus 8x plus, minus 48. And then they said x equals 3. So that means if x equals 3 is a 0, this means that x minus 3 is a factor. Similarly, if x is -1 was a 0, then this means x plus 1 is a factor. You're going to switch the sign in the middle, and that'll tell you what the factor is, okay? So this is just a side example. I'm going to erase it now, okay? So that's how you get a factor if they give you one of the zeros. So now that we have x minus 3 as a factor, we need to do a long division between those two. So we have to do x cubed plus 5x squared minus 8x minus 48. We're going to divide that by x minus 3 and do a long division. Let me write here that this is a factor from x equals 3. All right, so now let's do the long division. So again, we want an x cubed here. The only way to get an x cubed from x is if I times it by x squared. X squared times x is x cubed. X squared times -3 is -3x squared. So now I subtract, cancel these out. Two negatives here make it positive, so that's positive 3. 5 plus 3 is 8x squared. Bring down the -8x. All right, so now we're going to go ahead and say we need an 8x squared. So to get an 8x squared from x, I need to times that by positive 8x. 8x times x is 8x squared. 8x times -3 is -24x. Subtract. Now this cancels. Double negative is positive. So -8 plus 24 is 16. Bring down the -48. I need a 16x here. The only way to get that from x is if I times x by 16. So 16 times x is 16x. 16 times -3 is -48. And they all cancel each other out. So you get a remainder of 0. Which means that this can be written as these two factors put together. Okay, so let's rewrite that. So this means that x cubed plus 5x squared minus 8x minus 48 can be written as x minus 3 times our quotient x squared plus 8x plus 16. This is almost fully factored, right? We have it factored, but this can be factored further. How do we factor it further? Well, we need an x table. So we're going to set up an x table. 16 goes on top. 8 goes on the bottom. So two numbers that are times to 16 but added to 8. That would be 4. 4 times 4 is 16. 4 plus 4 is 8. So this can be factored as, let's just bring this down. Do a double parentheses for this. X plus 4, x plus 4. And this can be rewritten as x minus 3, x plus 4 squared, since you have two of them. All right, so this is officially factored. Okay, so we factored it. That's one of our things. So it says use long division to factor. So this is factored. What are the zeros and multiplicities now? So we want to find the zeros. So in order to find the zeros, we're going to set this equal to 0 and use the zero product property. So x minus 3 equals 0 and x plus 4 equals 0. Solve. So plus 3. So x equals 3. That's one of our zeros. Subtract 4 on both sides here. X equals -4. That's another one of our zeros. So those are our zeros. What are the multiplicities? Well, here for the multiplicity, how do we do multiplicity? We look at the exponent for each of the factors. So here there's an invisible exponent of 1. Here there's an exponent of 2. So this means here our multiplicity is 1 for x equals 3. And for -4, our multiplicity is 2. All right, so that's it for our multiplicities. Behavior. If you want to do behavior, well, if it's odd multiplicity, it crosses. If it's even multiplicity, it turns or touches. Turns/touches. I'm just going to say turns/touches. The x-axis. All right, and that's all that they wanted us to find out. Just if it crosses, turns, or touches, zeros, and multiplicities. All right, so that was number 21. Let's look at number 22. What is the vertex and axis of symmetry of negative 2x squared minus 8x plus 1? All right, so we want to find the vertex, so that means we're going to use the formula negative b over 2a. A is negative 2, b is negative 8. So we have here negative b over 2a. 2 negatives is a positive. 2 times negative 2 is negative 4, so 8 divided by negative 4 is negative 2. So we have the x-coordinate of our vertex. Now we need the y-coordinate by plugging this in. So plug in. So we have y equals negative 2 x squared, which is negative 2. So negative 2 squared minus 8 times x, which is negative 2, plus 1. Negative 2 squared is 4. Negative 8 times negative 2 is positive 16. Negative 2 times 4 is negative 8. And then we do the math here, and we'll get 9. So then y equals 9, so that's the vertex. So we got the vertex. They also want the axis of symmetry. Axis of symmetry is simple. All you have to do is, axis of symmetry is simply x equals to the x-coordinate there. That's it. X equals 2. That's all they wanted. Axis of symmetry and vertex. Done. All right, so moving on to number 23, we have completing the square. All right, so we want to complete the square for x squared minus 2x minus 1 equals 0. So let's go over completing the square. All right, so if we want to complete the square, first step is to move the constants over to the other side. So move the 1 over to the other side. Get all the x's on one side. So that's how you complete the square. That's the first step. Next step, put a little parentheses here, and you need to add a third term here. So if you want to, the way to figure out what this third term is going to be is you're going to use the formula. You're going to use b over 2 squared. So you're going to divide the middle term by 2 and then square it. In this case, b is negative 2 right here. So we have negative 2 over 2 squared. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So therefore, we're going to add 1 over here. Okay? However, if we add a 1 here, we need to balance it out by adding a 1 here as well. So we need to balance it out because I can't just add a 1 without balancing it. Okay? It has to be the same on both sides. Equal treatment. All right, so now that I have this, now I need to factor this. All right, so if I want to factor that, you can set up an x table if you like. Right, 1 factors of 1 to add up to negative 2. Well, that would be negative 1 and negative 1. So this now factors into x minus 1 times x minus 1, or x minus 1 squared. And that equals 1 plus 1 is 2. All right, we officially completed the square. Next, we want to get rid of this exponent by taking the square root. The only way to get rid of a square is by square rooting. Make sure that if you take the square root, you include the plus or minus signs. All right, next, now these cancel. So next you have x minus 1 equals plus or minus square root of 2. And now you're going to simply add 1 on both sides. So x equals positive 1 plus or minus square root of 2. So those are your two solutions. All right, we're going to do the same thing for number 24. Number 24, we have x squared minus 16x equals 9. Again, normally you would move the constant over, the number over to the right-hand side, but it's already moved, so we're good here. So leave yourself some room to complete the square right here. In order to figure out what to fill in the slot, I need to take the b over 2 and square it. So I need negative 16, that's this guy, that's b, over 2 squared. So that's negative 8 squared, which is 64. So you plug that in there. Since I added a 64, I need to add a 64 on the other side to balance it out. Right, so next I'm going to factor this left-hand side, so that's 64 and negative 16 on the bottom, and that's going to be negative 8 and negative 8. So this will factor into x minus 8 times x minus 8, or x minus 8 squared, equals, let's add these two together, 73. All right, so now to get rid of the squared, I need to do the square root, making sure to include the plus or minus symbol, sign. So we have x minus 8 equals plus or minus square root of 73. And then I add the 8 to both sides. And I get x equals 8 plus or minus square root of 73. Now 73, usually we would have to break it down, right? But in this case, I don't think 73 is broken down easily, if at all. So if it cannot be broken down further, then you don't have to do anything at all. Okay, so this cannot be broken down, so we're done. All right, so we can stop here. All right, next one. All right, this one's pretty easy. You guys will like this. Identify the number of real number solutions. This one, and there's another one which is the number of solutions as well that you guys will like. So x squared equals 5x plus 8. How many real number solutions does it have? All right, so x squared equals 5x plus 8. So first off, you want to make one side equal to 0. So make one side equal to 0, so move everything over to one side. Move that over by subtracting it, and then I'm going to move this over by subtracting it. Okay, so that's the first thing you want to do. Oops, it's going to be minus 8 equals 0. First thing you want to do, make that one side 0. And then you're going to use the discriminant. The discriminant formula is b squared minus 4ac. And what you want to do is, if that is greater than 0, you have 2 real solutions. If that number is equal to 0, you have 1 real solution. If that number is less than 0, you have no real solutions. And that's all you got to do. So you got to do that calculation. If you get positive, great, it's 2. If it's equal to 0, it's 1. If it's less than 0, it's none. So let's do that real quick. Well, a is 1. A is invisible 1. B is negative 5. C is negative 8. So let's do the discriminant. Equals b squared minus 4ac. Well, 5 squared is 25. Negative 4 times negative 8 is 32. So you get 57, which is greater than 0, which means 2 real solutions. Done. Okay, that's all you have to do. Once you calculate it, you get the number of real solutions. We'll repeat this for number 26. This is already equal to 0, so you can go straight for the discriminant. So discriminant, this is a, that's b, and that's c. So b squared minus 4ac, 3 squared is 9, 4 times 4 is 16. So this is negative 7, which is negative, less than 0, which is no real solutions. And that's how you identify the number of real solutions, using the discriminant. All right, we're hopefully wrapping up soon here. We're on number 27. There's a total of 33 here problems. So let's look at number 27. Almost at the end of our little marathon here. So we have linear quadratic system using substitution. All right, so let's solve linear quadratic systems. We know it's linear quadratic because you have a linear equation here and you have a quadratic here with that 2 as the highest power. All right, so let's solve that. Excuse me, it's 27. All right, so now in order to do this, all you got to do is, well, you see that y is equal to this, and y is equal to this on the bottom. So we're going to set them equal to each other, right? So we simply set them equal to each other because they're both equal to y, so which means that they both have to equal to each other. So all you got to do is set those two equal to each other and solve. Now this is quadratic because you have the power of 2 here. So we want to make everything equal to 0 on one side. So we're going to move everything to one side so that we have 0 everywhere else. Let's subtract this 36 as well. Might as well do the 2 steps in one. So you have x squared. Combine these, that's going to be plus x. It's going to be minus 72 equals 0. All right, there's our quadratic equation, which is equal to 0 on one side. So we should be able to factor this and solve it. So if we factor this, we got negative 72 on top, and we have an invisible positive 1 on the bottom. Two numbers that multiply to negative 72 but added to 1. Well, that would be 9 and 8, negative 8 to be specific. So then we could factor this into x plus 9, parentheses, x minus 8, using those two numbers that we found. And this is equal to 0. Then use the zero product property, ZPP. X plus 9 equals 0, x minus 8 equals 0. Subtract 9 here, add 8. X equals negative 9, x equals 8. So we solve for x. Next, we got to find y. Once we find y, then we get our coordinates, we get our answer, and that's it. So we need to plug these into the original. So let's plug in x equals negative 9 first into the original, into any of these equations, really. But since this is easier, let's plug it into this one, okay? Same thing for this. We'll plug this in later into the bottom equation. So we have y equals negative 12x, which is now negative 9, plus 36. Well, 12 times 9 is, what is that? 108, and 108 plus 36, yeah, 108 plus 36 is 144. All right, so that means one of our coordinates is negative 9, 144. All right, now let's plug in, that's one of our solutions. Now let's plug in x equals, what was our other answer? 8. Okay, let's plug in x equals 8. Same equation. Y equals negative 12x plus 36. Negative 12 times 8 is negative 96. Negative 96 plus 36 is negative 60. So that means one of our solutions is 8 and negative 60. All right. right, so those are our solutions for the system. All right, we're going to repeat this process for number 28. So again, this one's a little different because, you know, y is not solved on both sides. You only have this one with the y by itself, but that's okay. You can take this y, right, y equals that, and you can plug it into this y right here. So that y, this y now gets replaced with the box part. So now let's do that. So we get x squared. That y gets replaced with all of this, and then you have the plus x. So I'm just going to put this in parentheses to show you that that got plugged in for that. Plus x equals 5. There you go. There's our quadratic. Let's combine our like terms. And while we're at it, let's subtract this 5 over, because we want one side to be 0. 9 minus 5 is 4. Let's combine these. What's plus x and then negative 6x? That's negative 5x. Bring down the x squared. Now we have a nice clean quadratic function that is equal to 0 on one side. We can factor this. 4 on top, negative 5 on the bottom. Two numbers that multiply to negative 4 but added to negative 5 would be negative 4 and negative 1. So we can factor this. X minus 4, x minus 1 equals 0. Use the ZPP, product, zero product property. Set both of those equal to 0 and solve. Add 4 to both sides, add 1 to both sides. X is 4 and x is 1. All right, next we're going to plug in 4 and 1 into one of the equations. Let's plug it in to this equation right here for x. So let's plug in that. So we have y plus x, which is 4, is equal to 5. So subtract 4 on both sides. Y has to equal 1. All right, let's do the same thing for x equals 1. Y plus x, which is 1, equals 5. Subtract 1 on both sides. Y has to equal 4. All right, so then our final answer is 4 comma 1 and 1 comma 4. Using those two coordinates, x and y. All right, let's go to number 29. We're adding or subtracting polynomials. We can actually do that problem right. Actually, no, we'll need some space. So let's rewrite that problem. All right, so we have a double. Okay, so basically, we're going to subtract the like terms, okay? So we have here 2x squared minus negative 4. Okay, so we have 2x squared minus negative 4. Two negatives make it positive here. So we have 2 plus 4 is going to be 6x squared. So that takes care of those two. Now we have negative 1x take away 1x. So negative 1 take away 1 is negative 2x. Takes care of those. Positive 1 take away negative 3. Those two negatives become a positive. So 1 plus 3, that's going to be 4. So plus 4. That is all there is to it. It's just combining those like terms by subtracting them. All right, number 30. This one you guys will like because it's extremely simple. It's a gimme problem basically. Find the number of roots of a given polynomial. All you got to do, and I'll write the answer here, is you look at the highest power. The highest power is 6. Therefore, the number of roots is equal to 6. That's it. So we have 6 roots because the highest power is 6. So that's all they wanted you to do. For this one, the highest power is 7, so there are 7 roots. That's it. All right. Find all real and complex solutions. So let's do that over here for this problem. All right, so if we want to solve this, let's subtract 8 on both sides. Okay, notice that this is a difference of cubes. Remember that the difference of cubes is a cubed minus b cubed equals a minus b, a squared plus ab plus b squared. So that's the formula for the difference of cubes. So therefore, so what is the cube root of 64? Right? So if I were to write this as something cubed and then this as something cubed, how would I write it? Well, I know that 4 cubed is 64. 4 times 4 is 16. 16 times 4 is 64. So 4 cubed. And so it's going to be 4x. So 4x to the third gives us 64x to the third. Because of that, now I know that a is 4x. Okay, so I know a is 4x. Now, for 8, I know that 2 cubed is 8. So therefore, b has to be 2. So now I can plug into this formula. So I have a minus b, 4x minus 2. A is 4x, b is 2. A is 4x squared, a squared, plus a b plus b squared. I would just clean it up. 4 squared is 16, so this is 16x squared. 4 times 2 is 8, so this is 8x. 2 squared is 4. All right, so now we have it factored. Now we want to solve it, right? So this is now factored. They want us to find all real and complex solutions. So we're going to set this equal to 0 and use the ZPP. So we have 4x minus 2 equals 0, and then we have all this mess equal to 0. So let's solve this one. This one's pretty easy. Add 2 to both sides. And then divide by 4, and that's one of your solutions. All right, that one's done. Now this one, you got to use the quadratic formula. So that's A, that's B, and that's C. Actually, yeah. So actually what I'm going to do, I'm going to actually, because I know that 4 goes into 16, 8, and 4, I'm going to divide everything by 4. And that will make the numbers smaller so that they're easier to deal with. So this will be 4x squared plus 2x plus 2 equals, oh, actually we can, this should be 1. And that will make it simpler. So now I can just use a quadratic formula to get this right away. Notice that the numbers are easier to deal with. A, B, and C. So this simplifies it immensely. So quadratic formula is negative b plus or minus square root of b squared minus 4ac over 2a. So let's plug it into that. Negative b plus or minus b squared minus 4ac all over 2a. Then we get the numbers. 2 squared is 4. 4 times 4 is 16 over 8. All right, so we have negative 2 plus or minus square root of negative 12 over 8. So let's simplify this. Remember, that's negative, so it's imaginary, right? So I'm going to just take that, I'm just going to change it to positive, and I'm going to do imaginary. But break down the 12. 12 breaks into 2 and 6. 6 breaks into 2 and 3. So box your pairs. So that gets kicked out. This stays in the radical. So we have, for the radical part, we have the 2 gets kicked out. The 3 gets left inside with an I on the outside. All right, almost there. So now so split this up into 2 things. Split the 8 into those 2. And reduce your fractions. I can divide this by 2. Same deal here, divide that by 2. And that will reduce our fractions to -1/4 plus or minus 1 square root of 3 over 4 I. There's an invisible 1 there. All right, so we got that's our final answer. So we got the box part there and the box part here. So those are 2 solutions, or 3 solutions, I mean. 2 imaginary, 1 real. Right, we're looking at our last one now. Which is 9x squared equals 4. So we're going to subtract 4 on both sides. We get 9x squared minus 4 equals 0. This is a difference of squares. So a squared minus b squared equals a plus b, a minus b. Here, a has to be 3x because 3x squared is 9x squared. B has to be 2 because 2 squared is 4. So now we know A, and then now we know B. So we're going to plug it into these guys. So we have A plus B, A minus B. Set that equal to 0 and solve. 0 product property. Subtract 2 on both sides. Here we add 2 on both sides. So this one's 3x equals -2, 3x equals +2. Divide by 3 on both sides. X equals -2/3, x equals +2/3. There you go, those are our solutions. All right, that was a lot to work with, but that was the concepts that are going to be tested on the midterm. Like I said, you're going to have to show your work, but you should be able to match the answers to the multiple choice. However, just show your work so that you can match it up to the correct answer, and just study the concepts here, and you should be fine for the midterm if you understand how to do these processes. All right, best of luck, guys, and I'll see you in the next video.